Now, let's do numericals, which are based on lens formula and magnification. Before that, let's recall the lens equation, which was 1 upon f is equal to 1 upon v minus 1 upon u. And I hope you remember f is the focal length, v is the distance of the image, and u is the distance of the object. And magnification is given by m is equal to v upon u, and it is also equivalent to I upon O, where I is the height of image and O is the height of the object. Let's recall the sign convections. Now children, whether it is a convex lens or a concave lens, remember the object distance will always be negative. It is an easier way to remember that whether convex or concave, the object distance has to be negative. When you talk of the image distance, then the image is of two kinds, real and virtual. Real and virtual images are formed only by convex lens, not by concave. Concave forms only the virtual. So for real image, the distance is always positive, and for virtual image, it is always negative. Then the focal length, you will remember, for convex lens is positive and for concave lens it is negative. Now, when you talk of the height of the image, then the image again, if it is a real, then it is formed below the axis, so it is negative. And if it is virtual, it is formed above the axis, so it will be positive. So real images always, whether it is convex lens or concave lens, will the image will be negative, and the real image will be negative and virtual image will be positive. So now let's start with the numerical. The first numerical is an object is placed at a distance of 10 centimeter from a convex lens of focal length 12 centimeter. Find the position and nature of the image. So over here, you are given the object distance, right? This distance is object distance, and he is given it is convex lens. So we can say u is equal to, we'll apply the sign conventions and say minus 10 centimeter. The focal length, it is convex lens, will obviously be positive, so it is 12 centimeter. Now, the lens formula says 1 upon f is equal to 1 upon v minus 1 upon u. So, when I substitute the values, I'll have 1 upon 12 is equal to 1 upon v minus 1 upon minus 10. So, you will have 1 upon v. I can rewrite this as 1 upon v is equal to 1 upon 12, and this will become minus minus becomes plus. When you take it on the other side, it will become minus 1 upon 10. So this will give me 60 LCM, 5 minus 6, and finally I get this as minus 1 upon 60. Therefore, V is equal to minus 60 centimeter. Now, over here, the thing is that after doing these calculations, you can even think and verify like this. The convex lens is of focal length how much? 12 centimeters. And the object is placed at 10 centimeters. That means the object is placed between where? Between the optical center and the focus. Since the object is placed between optical center and the focus, obviously the image form will be virtual, right? And since it is formed virtual, so your image distance will be what? Negative, and your answer is coming out to be negative. Clear? So from here you very easily know this. And if you talk about this, that V is negative, so your image form will be also what? Virtual. So now the next question. A 5 centimeter tall object is placed perpendicular to the principal axis of a convex lens of focal length 20 centimeter. The distance of the object from the lens is 30 centimeter. Find the position, nature and size of the image form. So over here, which lens is given to you? You are given convex lens. Since you are given convex lens, so obviously f will be equal to 20 centimeter, and this will be what sign? Positive sign. Then your height of the object, that means O, is 5 centimeter. Then they have given the distance of the object, that means U, and whether it is concave or positive, the distance is always taken to be negative. So it is minus 30 centimeter. Again, write the formula, substitute the values. Rewrite the equation. And this you will get it as 1 upon 60. So your V will come out to be 60 centimeter. Now since the first part is solved, the position, right? The position is what? 60 centimeter. Now this is coming out to be positive. That means what kind of image is being formed? Image. The nature of the image is going to be what? Real. Now the size of the image form we can calculate from here. We know the magnification I upon O is equal to V upon U. We need only this portion. So now the size of images to be formed, so I, and this is given to be 5. This is equal to V. V we have calculated to be 60 centimeter, and U is how much? Minus 30. So that means I will be equal to minus 60 into 5 upon 30, which is coming out to be equivalent to minus 10 centimeter. So again, the size of the image is 10 centimeter, and this negative sign is again showing that the image formed will be inverted, isn't it? So it is going to be real, because only real images are formed inverted. And again, see, very easily you can know that when the focal length is 20 centimeter and the object is at 10 centimeters, that means it is placed between what? It is placed between F and 2F. So you very well know when the object is placed between F and 2F, where will the image be formed? Beyond 2F. So 60 centimeter is proving that your answer is right. It has beyond 2F, and obviously the image formed is what? Magnified. So object was of 5 centimeter, image size is coming out to be 10 centimeter. So this way you will come to know that your calculations are correct. Okay. Now the next question is, an object of height 6 centimeter is placed at distance of 20 centimeter from a concave lens. Its focal length is 10 centimeter. Find the position and size of the image. Now over here you are given O, the object, equal to 6 centimeter. It is a concave lens, that means F will be equal to minus 10 centimeter. Object is placed as a distance of 20. Object distances are always negative. So U will be minus 20 centimeter. Now we have 1 upon F is equal to 1 upon V minus 1 upon U. Let's substitute the values. 1 upon minus 10 will be equal to 1 upon V minus 1 upon 10. So this will give me, so children, V is coming out to be minus 5 centimeter, right? Now, you also come to the fact that I upon O is equal to V upon U. That means I upon 6 is equal to minus 5 upon minus 20. This is giving you 1 upon 4. So, I will be equal to 6 upon 4 equal to 1.5 centimeter. Now see the position that you were asked. This you were asked in the position. The position is 5 centimeter. Size of the image is coming out to be 1.5 centimeter. And you can see yourself, it's a concave lens, isn't it? And the image will be diminished. So when you are getting this as object is 6 centimeter, the size is coming out to be lesser. And similarly, a concave lens always forms a virtual image, and you get this as a negative sign, which justifies that your calculations are correct. Now let's proceed to the next question. The next question says, at what distance from a converging lens of focal length 12 centimeter must an object be placed in order that an image of magnification 1 will be produced? Before we proceed, I hope you know that if you want magnification 1, then the size of the image and the size of the object should be same. When is this possible? Obviously, when the object is at the position of 2f, then the image is also formed at 2f and the size is the same. Now, when the focal length is 12 centimeter, that means the object should be at 24 and the image formed will also be 24. This is what we can recall. Then, M is equal to I upon O is equal to 1. This implies that I will be equal to O. So the size of the image and the size of the object have to be the same. This is possible when your object is at 2f. 2f is the position. When the object is at 2f, the image is also formed at 2f. So your F over here is 12 centimeter. So the object should be placed where? At 2 into 12 equal to 24 centimeter. So this is one way of doing. And you can also use the formula to get it. Like from here you get V upon U is equal to 1. So V is equal to U. Over here, 1 upon F is equal to 1 upon V minus 1 upon U. That means 1 upon 12 is equal to 1 upon U minus 1 upon U. That gives me 2 upon U, or U is equal to 24 centimeter. So by formula also you're getting the same answer, and otherwise you can use the first method also to get this answer. Now let's move to the next question. The next is a concave lens has focal length 20 centimeter. At what distance from the lens a 5 centimeter tall object be placed so that it forms an image at 15 centimeter from the lens? Also, calculate the size of the image formed. So in this question, you are given focal length to be 20 centimeter and it's a concave lens. So F will be equal to minus 20 centimeter. Then you are given object to be of 5 centimeter. You want, the image is to be formed at 15 centimeter from the lens. Now, since it is a concave lens, we all know it forms only virtual image. So, in this case, V is equal to minus 15 centimeter. You need to calculate even the size of the image. So, first, let's find out the position of the object. 1 upon F equal to 1 upon V minus 1 upon U. Substitute the values. So you will get 1 upon u is equal to 1 upon minus 15 plus 1 upon 20. This gives me 60 as the LCM minus 4 plus 3 equal to minus 1 upon 60. So you are getting u equal to 60 centimeters. That means the object should be placed at 60 centimeters. Then the image will be formed at how? 15. And yes, I forgot that there's a negative sign also over here since the object and it is coming out to be negative. Object distances have to be negative. Then let's do the next part. You will have I upon O is equal to V upon U. So over here, I and O is given 5 centimeter. This will be equal to minus 15 upon minus 60. This will give you 1 by 2. That means I will be equal to 5 by 2 equal to 2.5 centimeter. Now see over here, this was a concave lens. The image had to be smaller than the object. Since the object is 5 centimeters, image size is coming out to be lesser. Moreover, concave lens always gives a virtual image and the height of the virtual images will be positive. So see, you have gotten the answer as a positive only. So this way you can also find out whether you're proceeding in the right manner. Then let's come to the next numerical. Next numerical says an object is 2 meter from the lens which forms an erect image 1/4 the size of the object. Determine the focal length of the lens and what type of the lens is this. Now in this case situation, uh, object is 2 meter from the lens. Whatever lens may be, you all know object distance is always negative. So u is minus 2 meter. This is one thing. Now let's suppose that the height of the object is x. Then what will the height of image will be? Height of image will be 1 by 4x. Right? So this is what we have got. Then we know I upon O is equal to V upon U. This means I can write V upon minus 2 is equal to 1 by 4x upon x. This means I get V is equal to minus 2 upon 4 is equal to minus 1 by 2, right? So this is the image distance minus 1 by 2. Now use this 1 upon f is equal to 1 upon v minus 1 upon u. So 1 upon f is equal to, now this is 1 upon v. So that means 1 upon minus 1 by 2, right? Minus 2. So when you solve this, you will get this as 2 plus 1 upon 2. So F will be equal to 0.66 meter. Since you are getting F as positive, so this shows that the lens is going to be what? Convex lens. And you can see that you are getting, your object was at minus 2 meter. This distance is coming out to be minus 0.5 meter. This means that the uh, object is, image distance is negative. This means again that the image is formed at the same side of the lens. So obviously it had to be a virtual image. So with this, we end up our session.